Welcome to the Day in History for April 24th. Today I'm super excited because it's about the Hubble Space Telescope. Today is the day the Hubble Space Telescope is launched on the Space Shuttle Discovery. Okay, we are located in the Earth orbit, specifically low Earth orbit, and the object of interest is a giant polished mirror. Let's write this down. All right, here we go. So, like I said, we're in low Earth orbit. Now, the Hubble goes around the Earth every 95 minutes, traveling at a speed of 17,000 miles per hour. So, every hour and a half, it goes around once. Now, the telescope's a pretty interesting thing. I'm not going to give you a big history of telescopes, especially for the people that have been to my macro-micro lesson. But most telescopes that we have today are on the ground. For example, you see this one here? Guess what? Check this out. Oh, I have my own. It's just like that one. And I'm actually going to start getting it out because it's getting warm enough at night where I can take it out. But this is my new fancy telescope, and it has like a 10-inch mirror. So 10 inches. And it's pretty big. Like this is, I think it's about a $1,200 telescope. I have a big tripod that it sits on, just like you can see in the picture here. But ground-based telescope. Now, these are the Keck telescopes in Hawaii. These are huge telescopes. We call them observatories. Some of you guys have been to an observatory before. But they share a common problem that my telescope has, the atmosphere. Now, when you look up through the atmosphere, you're looking through the layers of the atmosphere. And we talked about the layers of the atmosphere in some of our air lessons. And those layers of atmosphere have particles that make the light bounce and wiggle so that you don't really get a super clear image. I mean, it's pretty clear, but it's not as clear as it can be. And the farther away you look, the blurrier it gets. And so we ran into a problem. And we made this, the Hubble Space Telescope. It cost, well, it was supposed to cost $400 million. It ended up costing about $5 billion. And by the year 2010, after servicing it and keeping it going and everything, it was like $10 billion. But still, it was in space. And it worked really well. Now, it has a mirror that is 94.5 inches. That's pretty big. It's about as big as a school bus. Yeah, I know, pretty crazy. But the pictures it took and continues to take, if you look in Teams, I posted the 30th anniversary because today's its 30th birthday. Its 30th anniversary picture. But look at this photo. Isn't that amazing? How about this one? And this is one of the most important because this one actually looks back in time. This is called the Hubble Deep Field Image. And what the scientists did is they found a part of the sky that had almost nothing in it. Because depending on where you look, like if you try to look through the Milky Way, you know, if you look up in the sky at night and you see the Milky Way up there, if you try to shoot a telescope through that, you run into all kinds of stuff. So what scientists did is they found a really area that had nothing in it, and they just let the Hubble Space Telescope focus for a while, and they actually were able to see back in time 13.4 something billion years. Isn't that crazy? There's a lot more research you can do on that. Okay. It even took pictures of the moon. Isn't that crazy? That's the Apollo 17 moon landing site. That's a pretty amazing picture. Yeah. Now, the Hubble Space Telescope actually got its start back in 1946 by a gentleman named Lyman Spitzer. He's a famous astronomer now. But he wrote a paper about how if we could put satellites in space, then we wouldn't have to deal with the atmosphere. We wouldn't have to deal with the layers of atmosphere that makes our images blurry. And people said, well, that's a pretty good idea, right? And so they eventually started to fund it. Now, the Space Telescope, the Hubble, got funded. It actually started getting paid for in 1970. Yeah, it took 20 years because it launched in 1990. And they wanted to launch it in 1983, but then it got delayed because there was technical problems, and we'll talk more about that in a minute. So they started building it, and they said it was going to cost $400 million. It kind of went over its budget. Now, they did a bunch of tests before just to make sure astronauts could still work on this thing because it was a huge telescope. It was the size of a school bus. It was like a space station. Now, they finally launched it in 1990, 7 years after they had planned, because of like technical difficulties. And then in 1986, because of the Challenger disaster, which stopped all space shuttle launches, it took a while to finally get it to launch. But when they launched it, people were super excited. Now, the very first image that came back was this, and it was kind of like your test image. Nothing fantastic, nothing amazing, but they showed that it worked. Now, they decided to look at something a little more interesting than some black and white stars, right? And so they looked at this star, but then you know what they realized? Something was wrong. Something was really wrong. Because the image, the really, really blurry image, is a picture of a ground satellite. So, I mean, a ground telescope took that picture. The second image is the image that they saw when they first launched it. And the third image is when they got it fixed. We'll talk about that in a second. Now, look at this one. So, the image, the blurry image, is when they first started taking pictures. And the other one is when they fixed it. Because what happened is they ground the mirror wrong. Now, when you make a mirror for a telescope, you actually grind it. You can actually kind of see that little machine. It looks like it's got a disc on it, a silver disc. It's actually grinding the glass or the mirror down to just the perfect amount. And what had happened is the mirror had been ground just a tiny bit off. 1/50th the length or the width of a human hair. So if you take a piece of your hair out and you look at it, and then you divide how wide it is by 50, that's pretty small, right? That's how, that was the mistake on the mirror. And so what happened is when they finally, so when the light came in, it bounced the wrong way and it made the pictures blurry. We spent $5 billion on a telescope and we made the mirror wrong. It was actually all over, it was really embarrassing for NASA, to be honest. It was all over the news. They were kind of making fun of them because, I mean, you spent $5 billion and your telescope doesn't work right. So 3 years later, they came up with a plan and they launched it and they built what's called COSTAR, which pretty much was a pair of glasses for the Hubble. It stands for Corrective Optics Space Telescope Axial Remedy or something. Okay, fancy acronym. But they put this on there to fix it, and you know what? It worked. This is a picture of I think this is the Ant Nebula from the ground, and one with the new space telescope. Look at that. That's pretty amazing. And what about this one? So all of a sudden, we have the most amazing pictures. If you Google Hubble Gallery, and I highly suggest you do this, you can see the hundreds and hundreds and hundreds of pictures the Hubble Space Telescope has taken. Absolutely amazing. Gives us a huge amount of information on our world today. Now, in 2021, they're planning to launch the James Webb Space Telescope, which is even bigger. Now, the Hubble had a 94.5 inch mirror, okay, which is like 2.4 meters. That's pretty big. This one, 260 inch mirror. Can you imagine how much better the pictures are going to be with a 260 inch mirror? If the Hubble has a 95 inch mirror and then you almost triple it, oh my goodness. I cannot wait to see what the James Webb gives us. Okay, thanks guys. See ya.